Now we want to look at how to solve a logarithmic function. So one thing when we're solving a logarithmic function versus an exponential function is that in an exponential function, I was not needing to check my solutions. The reason for that is that in an exponential function, if you think back to when we were graphing them, the domain is all real numbers. So it didn't matter what x value we got, it would work. However, in a log function, our domain was restricted to be on one side of the vertical asymptote, right? So when we are solving a logarithmic function, we have to make sure in the end we go back and we take that solution, we plug it back into every place there was a log function and make sure that we get a positive value. So we have to make sure that it is greater than 0. Now it cannot equal 0. If it was equal to 0, that means that the solution would be on the vertical asymptote. And we know that you cannot be on an asymptote. So therefore, when we go back and we plug in our solutions, it has to be greater than 0 for every log function that's in that equation, all right? So that's one extra step that we'll need to take that we did not need to take in an exponential function. All right, so let's look at how we might solve a log function here. We're going to look at kind of two scenarios. One scenario would be that I have a single log, or I can get into a single log function, but I still have a constant left. Therefore, I can get the logs on one side of the equation isolated, but on the other side of the equation, I would just have a constant or a number, meaning that I do not have logs on every single thing in the equation. Our other scenario that we'll look at in a few minutes is when I do have a log on every single element in that equation. All right, so there's two scenarios. Logs are not on everything versus logs that are. So we're going to start off with saying that logs are not on everything. Logs not on everything, okay? So when we look at this, we've kind of got two scenarios inside of this. We'll look at a couple examples and you'll see what I'm talking about here. But the idea when we are looking at logs that are not on everything is that eventually we are going to use the idea of rewriting into an exponential function. So we did that when we were solving exponent functions, right? We were able to take the exponent and rewrite it as a log. We're going to do that same thing here. We're going to take the log and rewrite it as an exponent. The only thing is we have to do maybe a couple things first. So two things might happen first. Either I only have one total log in the entire equation, and so I isolate it. Second case is that I might have multiple logs, so I need to condense before I isolate, okay? So let's look at each of those scenarios so we can see what's happening, all right? So let's say, for example, our first equation we have log base 5 of x plus 3 plus 7 equals 12. All right, now, when I look at this equation, I notice that I only have one logarithmic function on here. So that means I need to isolate this log to be all by itself on that left-hand side. So the first thing I need to do is I need to move this 7. So moving that 7, I'll get log base 5 of x plus 3 equals 5, right? Now what I want to do, now that the log is isolated, I want to rewrite as an exponential function. All right, so remember when we rewrite, I'm going to take the base of the log, raise it to that 5th power, and set it equal to the x plus 3. So now 5 to the 5th is 3,125 equals x plus 3, and then I'll just continue to solve by subtracting the 3. So I would get 3,122 equal x. So I've now solved it. So to make sure that this is actually the answer, I'm going to have to go back and I'm going to have to check my solution. So I'm going to go back to any log function that we have, and I'm going to make sure that when I plug this in, so when I go back and I take 3,122 and I add 3, right, because x plus 3, I need to make sure that I get a positive number, which I do. It is positive. So that means that this is indeed my answer, right? So when I'm done, I just go back and verify that I get a positive answer. All right, let's try another one. Okay, so let's say that we had something like log base 3 of x plus 4 minus log base 3 of 2x equals 1, right? So now this one's a bit different because what I notice here is that I have more than one log on that left-hand side. So I can't isolate, because if I wanted to isolate, that means I'd be moving the log to the other side. No, remember, I want all logs on the same side. So instead what I need to do is I need to condense the logs. So remembering my log properties, subtraction is going to become division. So I'm going to divide this so it'll look like log base 3 x plus 4 divided by 2x. So I have to remember that condensing logs properties. Okay, so I use the quotient property there. Now that I have a log all by itself, I'm going to rewrite into an exponential function. So I'm going to take this 3, it's going to become my base. I'm going to raise it to the first power and set it equal to that x plus 4 over 2x. All right, so now 3 to the first power, well, that's still 3. So I'm going to keep solving here. So right, I've got a fraction. I need to get rid of that denominator. I'm going to multiply it. Since it's being divided, I need to now multiply. Continuing to solve, I'll subtract that x and divide by 5. So x is going to equal 4/5. So I need to make sure that that works. So I'm going to take this 4/5. I'm going to go back to each of these two places. So I need to make sure that when I plug it into x plus 4, I get positive. So 4/5 plus 4, that indeed is positive. So that works in the first one. Now I go to the second one, which is 2 times 4/5, which also gives me a positive answer. So now that it works in all scenarios, I can say that it is my answer. So I have to be careful because I can't just simply plug it into one of the logs. I have to plug it into all of the places where I had a log and make sure that I get something positive. All right, so we could have something where we are solving it, where we have a single log, isolate it, rewrite it as an exponential, solve. I could have multiple logs where I condense it, rewrite it, solve it. Every time I'm making sure I'm checking in the end.